Hello everyone, I hope you remember our last lesson. Today we are discussing probability and combinations. The previous video on factorials and permutations is very important since it builds up a lot of what we know in probability. And one of the best ways to teach it is by using cards. And the perfect anime that I can think of that uses cards is Yugioh. I understand that not everyone plays Yu-Gi-Oh, but don't worry, we're going to go with the basics. First season, episode 1 rules. Normally the game starts off with 8,000 life points and the goal is to get your opponents down to 0. But that's not the only way to win in Yu-Gi-Oh! One other win condition is to summon Exodia. So how do you summon Exodia? In order to win with Exodia, you need to have all of its parts in your hand. Its head, 2 arms, and its 2 legs. A total of 5 unique cards in your hand. This is an extremely hard task normally, but there are decks specifically designed to summon Exodia, which makes a win condition a lot easier and consistent. In fact, it's possible to win in the first turn with these decks. This is also known as the FTK, or the first turn kill. Crazy, right? To be able to win without your opponent being able to do anything? This is actually not an unheard of occurrence in the Yu-Gi-Oh community, and a popular way of doing it is with the Exodia deck. And with this video, I'll show you how likely it is that this can occur. I'll be using math to find out the probability of winning in the first turn. There are so many variants of the Exodia decks. The Yu-Gi-Oh card game has been out since 1999 in Japan and 2002 in North America. Since the beginning, Exodia has always existed. By then, there have been multiple cards, decks, and strategies designed to help summon Exodia. Instead of choosing what could arguably be the best Exodia deck, for this video I'll be using a deck based on the series itself. The Seeker is a character who specializes in summoning Exodia, and we'll be using his deck. I wanted to use a more up-to-date deck list, so we're going to use his deck from Yu-Gi-Oh! Legacy of the Duelist. As we look at his deck, you'll notice a few things. One rule in this game is that you can have a max of 3 copies of the same card. As you can see, he has a max of 3 cards for each piece of Exodia, making it 3 times more likely to get said pieces. A really popular Exodia strategy is to accelerate the process by drawing as many cards as possible and as soon as possible.
The Graceful Charity card allows me to draw 3 new cards. I play Graceful Charity again!
Again?
Yes, a good hunter must acquire strong hounds to replace the weak ones. So I discard 2 old cards and I summon Exodia the Forbidden One!
It is also why there are multiple copies of these cards in his deck. Graceful Charity, Upstart Goblin, Pot of Duality, and the infamous Pot of Greed. These are the cards we will be focusing on in this video. If you keep drawing all these draw cards, there is even a possibility to draw up to 18 cards in one turn, which is huge considering that there are only 40 cards in the deck. The rest of the cards in this deck doesn't accelerate the process of gathering the Exodia cards, like Red Eyes Black Dragon. But there's also Reckless Greed. While it helps you draw cards, it is unfortunately a trap card, and you can't use them in the same turn. And if you can't use them on the first turn, it's not going to help you get a first turn kill. So I mentioned a bit about probability. So what is it? Probability is the branch of mathematics that revolves around how likely an event were to occur. And an event is defined as an outcome or a defined collection of outcomes. The probability of an event is interpreted as events that we want to happen over the total number of possible events. Using the dice as an example, there are 6 numbers but only 3 of them are even. So the probability of getting an even number is 3 over 6, 1 over 2, or 50%. So now that we have the basics about probability, let's talk about combinations. So in the Katana Katari video, we discussed about permutations. This is used when you want to find out the number of events when the order matters and the repetition doesn't. But in combinations, we don't care about the order. What does that mean? Well, let's say you draw 2 cards from a deck of playing cards. First you draw Ace of Spades and then an Ace of Hearts. In a different scenario, it's the opposite. You draw Hearts first instead of Spades. Under permutation, these are considered 2 different events because the order is different. However, under combinations, it's the same thing. This is because they are the same 2 cards, and it doesn't matter which card you drew first. How do we calculate the total number of combinations? Well, permutations are interpreted as n factorial over n minus k factorial. Well, we're going to divide it again because we don't care about all the similar stuff. Think about it as filtering out all the similar outcomes. So if k is how long the sequence of things are, then k factorial is the total number of sequences. Thus, we're dividing it by k factorial. Then the equation for combinations is n factorial divided by k factorial times n minus k factorial. I'm going to be using the Yu-Gi-Oh example. In the beginning of the game, you draw 5 cards. and one more during your draw phase. This makes a total of 6 cards in your hand in the first turn, and we can use combinations to find out how many possible first hands there are. Previously, we described what N and K are in permutations. In combinations, we describe this as N choose K. N stands for the total amount of choices, or in this case, it's the number of cards in your deck, 40. K stands for the choices that we want to see, aka 6, the number of cards you drew. Thus, this is 40 choose 6. In other words, how many unique ways you can draw 6 cards out of a 40 card deck. 40 factorial divided by 6 factorial times 34 factorial, this is equal to 3,838,380. There are almost 4 million ways this hand could go. So out of those 4 million ways to get a first hand, how many of them will get you a first turn win? Well, from what we know about probability, we need the total number of events and the desired events. We found out the total ways a hand could go when you draw 6 cards. However, we're playing a deck of cards that draws even more cards. So our hand will end up drawing 7, 8, 9, or even more cards from the deck. The number of cards that we end up drawing from the deck will help determine the denominator, like we did for 40 choose 6. Now all we need is the numerator. So how do we calculate that? Well, for this video, I'm going to use the most likely given scenario, which means 4 pieces of Exodia are already in the hand. If we have less unique Exodia pieces in hand, this video will be a lot longer, as there will be a lot more possibilities. I just want to give you a small sample of a very close possible FTK situation. From there, that means 4 of those 6 cards in your hand are Exodia pieces, and the last 2 could be one of 3 possibilities. The first possibility is that you draw a useless card, and that doesn't help us get Exodia in the first turn. For example, Red Eyes Black Dragon, or a piece of Exodia that we already have. We don't care about this outcome. The second and ideal outcome is that you draw the last piece of Exodia, winning the game. And the last possibility is a draw card, helping accelerate the process to find the last Exodia piece. It's also kind of like a second chance, where it can be any of the 3 outcomes again. And there will always be a possibility to draw cards, as long as there's at least one draw card in the deck. So considering that we only need the Exodia or draw cards outcome, that's all I need to calculate. Well, let's talk about the draw cards first. There are 3 copies of each draw card with the exception of Upstart Goblin, which has 2 copies. Upstart Goblin allows you to draw 1 card. Pot of Duality allows you to draw 1 card, but you can only do it once per turn. Pot of Greed.
Pot of Greed lets me draw 2 cards!
Now I play the magic card, Pot of Greed, allowing me to draw 2 more cards. Excellent. I play this, Pot of Greed. It allows me to draw 2 new cards to refresh my hand.
And Graceful Charity, which allows you to draw 3 cards, and then you discard 2. But we don't care about the discard part, as it doesn't help us draw any more cards, and it's not our focus. Alright, now that we got that out of the way, I'm going to present how we're going to find the probability of one scenario. I just want to show you exactly how we can find the probability, just to give you a small sample before I uncover all the other probabilities of dozens of other events. We got our 4 Exodia pieces, and let's say we ended up drawing 1 of each draw card. This means that we drew 1 out of 2 Upstart Goblins, 1 out of 3 Pot of Greeds, Graceful Charity, and Pot of Duality. I'm going to visually show you what this looks like. You get 1 useless card, then a draw card, and it doesn't matter which, the result is the same. Let's say it's Pot of Duality. You activate that and get Upstart Goblin. Then Pot of Greed, which gets you 1 useless card and Graceful Charity. You get 3 more cards from that, add them all up, and you drew a total of 13 cards in a single turn. Just to elaborate, this is not, can we get Exodia with these cards? It's, we got Exodia with these cards, how likely is it? There's a difference. We're basically gold experience requieming this shit. Now let's put combinations into the mix. We use 3 choose 1 to describe each Exodia piece that we got. Also, it doesn't matter which order or which limit is, so we use 5 choose 4. This signifies it could be any of the 4 of the 5 Exodia limbs. Like, one event is that we can have all the Exodia pieces but missing the left leg. Another event is that we're missing the head. By choosing 4, we're taking account that we got 4 unique Exodia pieces, and the fact that there is a piece missing means that there are more events. Now onto the draw cards. Remember that we said for the event that we would use 1 of each. Following the pattern, it's 2 choose 1 for Upstart Goblin, and 3 choose 1 for the rest. Now all of this is pointless if we don't draw that last unique piece of Exodia, and we only need 1 copy of the 3 in the deck. so just like everything else, it's 3 choose 1. But recall that we drew 13 cards in total, and counting all the cards we used, it's 5 Exodia pieces and 4 draw cards used. The remaining 4 cards can be anything else, which is another event. As long as it's not another draw card, the event has a total of 24 choose 4 possibilities. Multiply it all together, and you get the number of events you can win with Exodia, with 4 pieces already in your hand and 1 of each draw card. The number of ways you can get Exodia with 1 of each draw card is almost 700 million. Then dividing it all by the combinations of getting 13 cards in a 40 card deck, you get the probability. 40 choose 13 is over 12 trillion, making the probability less than 0.01%. However, that's just one outcome. There are dozens more scenarios like this, each with different number of draw cards. Rather than go through them all, one by one, we can use Google Sheets to do all the problems at once.
We're not cavemen! We have technology!
I made a column in Google Sheets for each possible number of times we drew the card. This comes to a total of 192 events for drawing the draw cards. I then used Google Sheets to calculate the numerator for each one, then the denominator for each one. So we have every scenario and their respective probability. How do we find out the total probability of winning in the first turn using this information? You add them. This can happen because they are all mutually exclusive events. Sum it all up, and the chances of you getting an FTK with 4 Exodia pieces is around 4.5%. Endnotes. There's actually a few things I want to talk about in this video. Probability is actually one of my most favorite math subjects, especially because of its applicability. 4% is actually really high in terms of winning in the first turn. But this is very unrealistic if you consider that almost every single card involved is either banned or limited in modern Yu-Gi-Oh! In retrospect, after doing this video, there could be a lot that can be improved on. There's actually way more than 192 possibilities, but I won't get into that detail too much. One example is that there's a possibility of Graceful Charity discarding draw cards, and that already messes everything up, and creates more possibilities. Once I revisit this, I'll do a lot more, and provide a more accurate percentage, and I like to do that with my other videos too. Mathematicians make mistakes all the time, and the good ones own up to them. Thank you for watching this video. If you like my content, like the video, and feel free to subscribe for more videos like this one. See ya!